Okay guys, in our last video, we looked at how we could take two or more complex numbers and find sums and differences. In this video, we're going to be looking at how we can multiply complex numbers. And the very first thing I want to mention is just that when we take complex numbers times complex numbers, we should always get a complex number result. And so that is to say that when we do this, we're always going to be able to write our new answer in standard form, this real plus imaginary part form. So in terms of how we multiply complex numbers, I'm going to give you a suggestion here, but we multiply either by using distribution or FOIL. FOIL when we have two binomial looking things multiplied together, but distribution when you have something kind of like letter A down here. So with respect to multiplying, we're going to treat it just like we do algebraic expressions. And even though I is not a variable, we're going to treat it like a variable when we manipulate the expressions. The second thing is just going to be we're going to simplify and write our answers in standard form. And so one thing I want to make sure we add up here before we start is just this. Remember that I squared is equal to -1. It's the only number that when I square it I get negative outputs. So when we look at these examples down here, and I say we're going to treat this just like algebraic expressions that maybe have x's, instead they have i's, I would look at this as just being a distribution problem. 3i times 2 minus 5i would be 6i minus 15i squared. Now I'll tell you first of all, that's the product. Now in terms of how I've written this does not look like a complex number in a plus bi form. So the first thing I want you to notice is that we have an I squared here. And simply put, whenever we have an I squared, we're going to substitute in a -1. And so something we're going to see pretty quickly here is just this. Anything that has an I squared attached to it, if you look at how it started here, I'll put that 2 back in, and how it ends up down here, you'll notice that that I squared is effectively just going to switch the sign of the thing it was attached to. So it becomes a positive 15. And last but not least, if we're writing this in standard form, we need to write it as 15 plus 6i is our complex number in standard form. Now you heard me mention FOIL. We can FOIL to find our product here between these two complex numbers. So let's go ahead and do so. We get 3 times 2, 6. 3 times -5i, I suppose that would be -15i. And we take our 4i, our inner, 4i times a 2 would be an 8i. And then a positive 4i times a -5i. Positive times a negative is a negative. We get -20, and this is important, we get I times I, or I squared. So for, I guess, complex numbers, when you're foiling them, there's always going to be a similar set of steps. The first one's going to be, let's combine like terms with our I terms here. So -15 and a positive 8 give us a -7i. The other thing is this, on the back, we're going to replace I squared with -1. So what we finally end up with is 6 minus 7i minus 20, minus 7i plus 20. And putting these finally together, 20 and a positive 6, we should get a 26 as our real part and -7i as our imaginary part. So you can see that foiling this out, it doesn't really look like it could ever be in standard form, but because we can simplify this I squared into a -1, we should always be able to write this in standard form. Now, what about something like letter C? Yeah, what about something like letter C? Well, I'll tell you, something like this, you would multiply it just like you would real numbers. We would multiply these two on the left first, get a new complex number, and then take that complex number times 2 plus 6i. Now, there is a reason why I use this particular product of factors. And the reason why is because we just did 3 plus 4i times 2 minus 5i on the left. So to put this into context, we would have to do this part first and then write our answer as a complex number in standard form, but then follow up with now taking this times that third complex number. So if we go ahead and FOIL these now, we would get 26 times 2 would be 52. 26 times positive 6i would be 120 plus 36, 156i. Here we'd get -7i times 2, so a -14i. And then a -7i times a positive 6i is a -42i squared. So again, let's clean this up. The very first thing is we tend to combine like terms in the middle. Looks like we get 142 i's, and that's positive. And then in the back here we have -42 times a -1, which is effectively going to make this a positive 42. So 52 plus 142i plus 42 Sticking these two terms together, now we get 94 as our real part plus 142i. This would be our complex number in standard form. So multiplying complex numbers in standard form, a lot like multiplying polynomial expressions, just that we need to be careful to rewrite I squared as -1, and we also need to be careful to rewrite this in the standard a plus bi form of a complex number. Cheers.